Oh yeah, we're back. Hi everybody, I'm Alexander Pascal, your community manager, and joining me today is Jack Porter, your engine dev and support lead. He has two titles because he's that important. Thank you so much for
That's
joining us
right.
all the way from Korea, Jack. Um,
Thanks, Alexander.
yeah,
To qualify, I'm not really engine development and support lead for all of Epic, just for all of Korea.
just all of Korea.
All of
It's
Korea. Yeah.
that's all. No big deal. But yeah, so thank you so much for joining us today, Jack. Before we get into the meat of things, though, first we have the news. There we go. Cool. So the first news item that's up today is 4.12.5. When we had the 4.12.4 update, I said I believe this will be the last one. I was wrong. This is going to be what we believe now to be the final one, because what we had found was, you can see it right here. There's only a couple things it fixes, but this one crash was particularly nasty, and we wanted to get a hot fix out there for you because it was, just causing some issues. So, nice new hot fix, gets rid of a nasty crash. Go get it. This one should be pretty small and easy to handle. Boop. Next thing to cover today. I've got a new video up called Welcome to Sequencer, and it's just a little short 1-minute clip that shows you all the features of Sequencer. Not going to be showing it off today, just want to let you all know that it is there if you want to see. And speaking of Sequencer videos, the live stream is now up in the archives from last Thursday, where we had the full showcase and the explanation and all that. So if you're interested in Sequencer, then we have those two things up for you now, so go check them out. They're pretty cool little resources. So, nice. Next up, last thing on the list today is the Epic and Unreal Dev set sail for the English Seaside. Develop Brighton. Basically, we're going to be having a bunch of people over at Develop Brighton. A lot of stuff's going down there. You can see we have a full blog post of it. Kind of want to say, long story short, we have a ton of amazing UE4 games to show off. Oh, look, The Siege and the Sandfox. I wonder if C.R. Wilson is in chat today to talk about his game. But yeah, that just tons of amazing games and experiences are in here. But also, Jess Hyder will be speaking at Develop. Head to room 1 at 2 p.m. on the 14th, and she will talk to you about UE4 support, Dev Grants promotion. You guys can see that. But so yeah, Jess will be there. It's great. You can go there and make fun of her, or watch. Just be nice to her. She's a very cool person. But yeah, so that's awesome. And yeah, Develop Awards. So yeah, check out that. If you're going to be there, we'll have a lot of people there. I will not be personally attending, but we will have people over there. Cool. Now then, before we get right into the meat of everything else, I have got community spotlights to talk about. First up, let's just jump on over to. Oh, sorry, Shelly. I scared you for a second there because I jumped to a different screen. She wasn't expecting that. That wasn't planned. Okay, there we go. So, over here, we have the top 3 karma earners of the week. Christopher again. Last week you were on the chart as well. Heap Cleaner at 200. You're new one as far as I know. And Shadow River and Old Favorite. You're always on here at somewhere on this chart. So, yep, thank you guys so much. To everybody else, thank you for participating. It's just really nice to see so many people in the community coming together, helping each other out. If you want to earn yourself a badge on the forums, for the Answer Hub Sage, all you got to do is come down here and get into the top 3 position by the time Thursday rolls around for the stream. So thank you all, and for everyone else, hopefully next week, right? Cool. Pew. Now we can jump into the meat of things here. We've got, let's see here, huge RPG-styled landscape showcase. Right. Gao contacted me to talk about this new RPG landscape they've been working on. It's gorgeous. If you're in the kind of like scene design world, I mean, ArcViz is the visualization of buildings. This is like NatViz, NatureViz, and it's just gorgeous work. It's going to go into a full open world production game, but for right now, they're just showing off all their really astounding assets. They're really great.
It really is beautiful.
Yeah, it's incredible. They have like these god rays coming in. It's very real, or
I
very
like
unreal. Okay, I'm gonna just not. We're
I
just
like
gonna
the way
not.
they've done the lighting in this.
Hmm.
Kind of contrasts what we had with the kite demo we had kind of more brighter daytime. This is kind of dusk and a bit of fog and
Yeah,
mist.
yeah, it's
Really
got
awesome.
deeper greens and more contrast between the dark shades in the background trees and the brighter shades of the foreground plants and foliage. Yeah, it's a very good use of lighting overall, and the quality of the renders are just phenomenal. So
Do you
I
know if
wanted
they
to
use
show it
any
off.
photogrammetry?
I think it says in here whether or not they did, but I honestly I'm not entirely sure, but I wouldn't be surprised. It looks super realistic.
Yeah.
Yeah, but just wanted to show it off to everybody. If you're working on a game project and you have a lot of nice screenshots or a cool trailer or a demo or something you want to show off about it, hit me up. Let me know. I love to show off all of the cool things that you've been working on, and it just like lets me know that or if you see something else someone else is making, just send it right over because I love to talk about these things on the stream. Speaking of other awesome things, this is something, well, I had put it in my queue not realizing that we were going to give them a dev grant, but I want to make sure that I also highlight that this is going to be a spotlight as well. But Mitch's VR lab, which we announced last Thursday in the $80,000 worth of dev grants announcement. He's getting some money out of that. It's really fantastic work, but this is just wanted to show you. This is a really great collection of videos. Mitch's VR Lab is a very great channel. And then this one in particular is actually what got me hooked on the whole thing. It's the Intro to Steam VR video. I'm not going to show you guys the clip, but you get the idea. It's just really good. It's start to finish. Go in, make a project, make it actually work, get it going on Steam. Very simple, fast, easy. So again, Mitch, excellent work. All right. Next up, a previous Spotlight member, I believe Jan's been on here before, but anyway, I wanted to show this off. A couple of people sent it to me actually. A few people had sent these images over to me because they're like, look at how amazing it is, and like I said, you don't have to send me your own work, but if you see something cool, send it to me. I want to show it off. But what he's done is he's made this really cool blur material, or smear, I should say, a smearing material that creates this Sonic the Hedgehog ball effect almost, and he's put it up on GitHub, and it's GitHub right here slash LUGGLD slash smearframe. So yeah, smearframe is what it's called. There's a tiny little dock on it here, but overall it's just a really cool material effect, and he's sharing it publicly, which is nice. It's almost right, Shelly.
I was trying to get the URL where you could see it.
Okay. Oh, I see. You're getting the name there. I thought you were trying to get the image. I'm like, it's not quite there. There you go. But yes, I'll also be posting that in the description and all that too. So thank you so much. But yeah, again, really cool. I'm sure a few of you have probably seen that making its way across Facebook and Twitter as well. Wanted to throw that one in there because it's pretty hot and fresh. Really cool. Pow!
Yeah, it's awesome.
Oh, look at that. And I just so happened to open onto this Protostar demo that we're going to be walking through in a second. But first, we should probably roll a clip to recap on what all came in the new mobile. Yeah.
We're gonna show the Protostar video, right?
Yeah.
Yeah. Okay. This
Just
is
come after everything.
So we've already done. Shortly after this was released, we did Smetis was on a Twitch stream talking about Vulkan and this Protostar demo we did with Samsung, right? So that was before 4.12, but those features from Protostar have made it into 4.12 as general mobile rendering features. So we'll just give people a recap of what they are, what we're about to be talking about.
All right. Yeah, and this clip is also available on the Unreal Engine YouTube channel. It just shows off, again, really quickly the different major features that came along with all of this. We'll be talking a little bit about Vulkan also, but mostly about the rendering features today.
There's some stuff here that's also not called out, the shadowing, the dynamic and static shadowing mixed in this scene particularly.
Oh, yeah.
But you'll see as the planet moves up, all the shadows are, the static shadows of the scene are blending with the dynamic shadows of the ball as it goes up there.
Oh yeah, you can really see it when it does that float in from the top, and then all the
Yep.
balls come floating up, and then you see the dynamic reflections and shading. Yeah, it was a lot of fun to show this one off at GDC because they just gave me one of the phone. It was, one of the phones that ran it, and I just stood around and played it at people as they walked by, and they'd all stop and stare and wonder if it was pre-rendered and all that. And it's always amazing to say, no, that's what it looks
No,
like.
no, it's running on this device. Yeah.
Yeah.
Like, wow.
Very
Yeah,
performant.
you can't see from the video, but parts of it are interactive. You can cause the particle explosions and things yourself. So it's very clear when you're playing with it that it's real time.
Oh, yeah. And then all the instant static meshes.
This is just, artists showing off, right? There's no technology here. It's just good artwork.
You're just like, oh, we'll put a lot of stuff out there. It'll be impressive.
Right.
It's a good mentality there, Jack. Oh, wow. Very cool. Yeah, it's very impressive features, and I'm just really excited to dive into these. So yeah, Jack, let's start it up. What can we talk
Sure.
about here first? How about GPU particles and everything that they're capable of?
Oh, we'll talk about post-processing first.
Oh,
That came up
post-processing first. How about that?
There's a few things in there. We started with the PC post-processing pipeline, and we tried to enable some more of that stuff on high-end mobile devices.
Mm-hmm.
This demo was in particular was for Galaxy S7, but kind of high-end iOS devices and other high-end Android devices are all pretty much capable of these kind of effects. So one of the first things we did was we ported the depth of field, the Gaussian depth of field from
Mm-hmm.
desktop. We didn't really add anything new to it. We just made it fast enough to run on mobile. We had to do a few kind of slight tweaks to it. We reduced the number of the texture taps it does for the blur to make the blur a little bit lower quality but faster. And we also downsample the blurred image by a half before we start all the blurring. But with the Gaussian, you can specify kind of the area that's in focus and the near and the far blur amounts. And those are calculated simultaneously, which uses a feature called multiple render targets, which is only available on ES3.1 devices. So
Yeah.
that's why this is a high-end feature. Otherwise, we'd be able to run it on lower-end devices.
Mm-hmm.
But when it's there, here you go. You can see the background is blurred, and then it fades out here.
Oh yeah, it's a very cinematic effect for the
Right, it just
cutscene
makes all the
moments.
background soft.
Mhm.
While we're introducing that little character at the start, that little ball is called Neutrino. When we introduce that, we want the people's eyes to focus on that, not the background. The background should be blurred out. So,
That makes sense. Yeah, because it's about
Yeah.
getting attention on one thing. And you said it's called Neutrino?
that little guy, that little ball, his name is Neutrino. Yeah.
Oh, okay. Okay.
That
I
little-
didn't know that. That's new to me. That's cool.
We went through a lot of iterations of how to give it personality, but we still call it Neutrino.
Yeah, I can see how you kind of did the classic Pixar, just take any given object and bring it life. And so kind of like how they did the lamps.
Particles. You can make anything to life with particles, right?
Yeah.
Some other things. We also support the filmic tone mapper.
Mhm.
There's a
Oh, there you go.
console. Oh, there we go. Oh, filmic tone mapper.
Wow, Shelly, you were on point with these cuts.
It was just
Yeah.
after.
There's a console variable called r dot film mapper. Sorry, tone mapper filmic equals 1. R dot tone mapper filmic equals 1 in the just in the console variables INI file. Or you can toggle it on and off as the engine's running. That runs pretty much on any Android device, although it runs better on higher end devices, obviously. And this uses the lookup table, and it really allows the artist to have full control over the color grading. There's in the 4.12 release notes, there's I think I did an animation turning it on and off in the protostar scene, and you can see what a difference it makes.
Oh yeah,
bring
you can kind of just see the color change suddenly pop. So yeah, if the 4.12 release notes
Yeah, you
also
can
have more
just-
details on these too.
Right, it brings out a lot of a lot of detail that you don't otherwise see. It really makes the scene pop. We had chromatic aberration and a few other things enabled as well for this particular demo. Those are also available in 4.12. Okay, so moving on to GPU particles, you can see lots of particles there.
Oh yeah.
These are, we're basically rendering the same way they get rendered on lower end PCs, like a DX10 card on a PC. They end up, we have a few textures which contain things like the particle's velocity and the particle's position. And then we render some pixel shaders over multiple frames. Each frame renders, we render the new position and new velocity for each particle. And that requires a couple of OpenGL-ES 3.1 features, so we only run on some a bit higher end devices.
Oh, all right. Yeah, people in the chat are asking about what kind of device, like what kind of GPU is required, like a Snapdragon 820 minimum or anything like that.
Yeah, it's listed in the release notes. I think
okay.
I'm just scrolling down to find it here. It's here we are. GPU particles. Yeah. Okay. So on iOS devices, it needs like an iPhone 6, iPad Air 2 kind of generation, which is pretty high.
Yeah.
That's because of the floating point, the 32-bit floating point render targets and multiple render target support we need for it. It's basically to store these positions and velocities, we need really pretty high resolution.
That makes sense.
Representation, and we also render kind of multiple things at once. There's multiple pieces of information about each particle, so that's why we use multiple render targets. We could probably make this work on lower end devices by doing things twice, but it just makes what's already a slower device even slower. So for now, that's where the cutoff is. We think GPU particles are a kind of bling effect to bring out really high end effects on the latest devices.
Oh yeah, I mean it's definitely the pure visual. Here's 1,000 things at you, and it's pretty impressive when you see them all swirl up and all that. Yeah.
The on Android 6 and above devices, it's actually available on what seems like slightly lower end. Galaxy Note 4, Note 5, S6, S7, Nexus 6P. So a bunch of slightly older devices that are still able to run it.
Yeah, but a Note 4 is still pretty powerful considering everything out there. So yeah, it's definitely on the medium high to higher end kind of stuff there.
Right. When the Note 4 came out, it was kind of slightly bigger form factor. They can put a lot of power into it, like Apple do with the iPads. Are always pretty powerful, right?
Yeah, well, yeah, because they're larger.
Yeah. You have a bigger battery. You can spend more heat. Those kind of things.
Yeah.
But yeah, GPU particles still have to be a bit of an optional effect for these reasons. One other limitation is, unlike PC, we do not support collision yet, so we can just simulate the particle's position, which is cool. But in PC land, we're using deferred rendering, which means we've got access to all kinds of depth and normal information, so we can do high quality collision and do nice bouncing off the surface because we know what direction the surface is pointing. On mobile, we don't have that, so we can't really do good collision, I'm afraid. So it's just purely a rendering.
I see. I'm sure that as things develop, that'll change.
In this scene, only those very small sparks were GPU particles. The rest of things were mesh particles and even individual meshes. As we talk about Vulkan, we'll talk about how we can do more draw calls, and it becomes less of an issue.
All right.
Having lots of moving objects on screen.
That makes sense. So can you play that one again? So the one where we're looking over like the lake and there's like a bunch of particles. Those are all the GPU particles you're saying, but when we're seeing we're seeing the other scene where there's like a bunch of balls in the air, then that's
the previous scene, shall we?
No, that's fine. You're all good.
Okay.
You're all good. Thank you so much, though. I love to throw curveballs at her while we're live. It's always great. But yeah, so when we're looking at this scene here, these are mesh
Most
particles?
of those balls are individual objects because you can actually you can actually tap them and they light up and they spark when you touch them, and they change their behavior when you touch them. So just those kind of all the rocks and stuff that appeared then, like the rubble, that stuff was GPU particles.
But like his trail is that's just like regular particle effect.
Oh no, his trail is also GPU.
GPU particles. Okay, cool. And the ones going over the lake, that's also GPU.
Yeah.
Oh wow.
So basically, each particle is being rendered as if it's a very complicated pixel. And so if you think about how many pixels you can render on the screen, that gives you some idea about, how many particles you can simulate quickly. So, tens of thousands is pretty reasonable. Actually, rendering those particles once you've simulated them is still expensive, because if they've all got translucency or whatever, they're all going to be spending GPU time to render them.
That makes sense.
So you still have to. They're not free, but they're still a lot cheaper to simulate than they would be if they were just regular CPU particles. The CPU would be doing this work.
Yeah, and then that makes sense as you're adding in more translucent materials, because they have to be in order to look like proper sparks and whatnot. Yeah, they're just layering up. They're going to eat up a little bit more. But yeah, this is a really good way to kind of mitigate some of that too. Yeah.
Yeah, even on PC, when we first released UE4, we had the Elemental demo, which was where we first introduced GPU particles, and those particles were very kind of metallic, sparky. We had millions of them, but their actual interaction with the scene was, for this reason, was lightweight. Right?
Oh, okay. That's a good trade-off to make then, because I mean, until you said it, I wasn't even looking for
more
it,
simple particles is obviously something that still looks impressive.
Yeah. Okay. Well, I'll have to look for it next time. That's pretty cool.
I should mention we do support the same vector fields. So in Elemental, all the particles were swirling nicely because we had vector fields, which basically this a 3D texture you set up with like little vectors pointing where the particle should move when it goes to which part of the volume. We do support those same vector fields for the GPU particles to make them move.
Yeah, and if anyone out there is not totally familiar with vector fields and all that, wants to learn about it, we actually have a content example for GPU particles in the content examples on the Learn tab. So check it out, and then you'll see exactly what we're talking about, because you can see there's one in there that kind of swirls the particles, kind of a similar way to the way that particles sort of swirl up in this. But vector fields are pretty impressive to look at, actually. The first time I realized what was causing it to happen, it was kind of like an aha moment. So definitely want to check those out if you're not familiar with them. Cool.
Okay, what's next? So I briefly mentioned others just for a fraction. We've had that for a while on mobile. And like I said, this is just content and artwork.
Shelley said it's pretty, and we're going to keep showing it.
But the feature I mentioned earlier was the shadows. And shadows have always been a problem with the mobile renderer. And that's getting good dynamic shadows for your player, as well as having kind of very cheap pre-calculated shadows from light mass on your static environment. And typically a mobile game is going to have a few 3D players, maybe a few 3D characters, plus a lot of very static environment that they're walking through if you're making a dungeon kind of game, or a game which needs shadowing. Obviously you can do simpler mobile games that don't need these things, but so we solved that an initial problem, which is static lighting with a dynamic character moving around still wanting to cast a shadow. We solved that first with modulated shadows, which is kind of a Unreal Engine 3 type technique we reintroduced for mobile, just because it was so lightweight. And that's basically, you render your scene, and then you draw your character, and then you draw like a dark shape of the shadow on top of everything. So it makes the static shadow that was already dark, it makes it even darker. They don't blend nicely together, and it's not physically accurate. But that was the kind of trade-off that you had to make in the olden days, and it was necessary. That's the kind of shadows we had also for like Infinity Blade in UE3. But for 4.12 or for Protostar, we decided we wanted to really solve this problem. And so the other thing you could do if you wanted to have really nice shadows is you could make your light completely dynamic, and then all of your static environment, and your player would be lit by what's called a CSM shadow, cascaded shadow map shadow. And you'd get very nice, accurate shadowing over everything, but it's very expensive to calculate. And also, it's not as soft as the pre-computed shadows that you get from light mass. So neither of those trade-offs were ideal for mobile. So for 412, we decided we'd do the best of both worlds, which is the pre-baked shadows for all the static geometry, and then having your dynamic player or your dynamic objects that need to cast shadows, casting cascaded shadow maps. So the CSM just renders the dynamic stuff. Yeah, so if you, all right, that's just a screenshot. But in the video, when you watch this, as the planet moves up, or the star moves up, you can see the shadows blend together nicely, because the CSM shadow is a full scene shadow, so it's available at the same time we're rendering the background, so we can blend it nicely with the pre-calculated shadows.
Yeah, I mean, that looks really great too when they blend together nicely like that. So that was a good trade-off. Yeah,
so they're a bit complicated to set up. You need to use a stationary light. Maybe I should talk about the difference between static, stationary, and dynamic for mobile. It's pretty clear cut for mobile, so I might as well. So a static light on mobile is completely baked into the light maps in light mass, and you can have as many of those as you want, because at runtime that light doesn't exist. You just have this pre-baked data for it. But the downside to that is that it means means any dynamic objects are not going to be lit or shadowed from this thing, because or they're not going to be lit except by the kind of indirect lighting information that we bake, kind of ambient lighting that we bake into the environment. So we use that for kind of point lights and things to add mood to the static environment, but typically you'll have a single stationary light in your mobile setup. So you have a single stationary light, directional light, and that will cast the shadows for the player, and it will cast and there's a checkbox saying there's two things. There's a project setting, which needs to be, it's enabled by default, but it can be disabled if you don't need it, which is called something like, let's check what it's called. It's under mobile. Project settings.
Maybe I can bring it up on my screen too and show them.
Yeah, people
it's an editor.
It's under rendering mobile.
Wait, what preferences or settings is it under?
It's not it's project settings.
Oh, it is project settings. Okay. Yes, and then rendering mobile. Right.
There it is. Oh, it's at the top.
I did. It was at the top because this is not alphabetical order. That's what I was expecting. There we go. Cool.
There we go. Yeah, it's the bottom option there of those four, which is called Enable Combined Static and CSM Shadowing.
There we go.
It's turned on by default. But it's a project option mainly because it uses one extra texture sampler. So you could free up that texture sampler for your own use if your game doesn't need this feature. So we went and turned that off for example, Sun Temple, because we were running out of textures with this enabled. Like everything on mobile, it's a trade-off, unfortunately. I'll get to that in a little bit as well about how we can solve this problem better in the future. But so right now, yeah, you need to make sure that option is turned on, and then the directional light, a stationary directional light, will have a property named something similar to use combined and static and CSM shadowing. And with that setting turned on, you can you're able to use. It will go off and find the dynamic objects that need to cast the shadows and build CSM shadows for them. Finally, there's one other setting you need to change.
Oh, I can go in here and show it again. Project settings.
It's not a project setting, I'm sorry. It's a setting on the background. If you could just click the floor in this scene.
Oh, I could if I had that turned off. Okay, there we go.
There's a under mobile, there's a mobile category on the properties.
Wait. What? Oh, okay.
I think you haven't selected the floor there. I think you might have selected something.
I selected a planar reflection.
Yeah.
That's my bad. Now I've got the floor.
Yep. If you scroll down there, there's a mobile category.
Did I just go past it? Maybe it's at the bottom. Mobile. There it is. It's tiny.
Yep.
There you go.
And there's only one option there. We had some complaints about this in the forums, and we always knew when we released 4.12 that this was a pretty big compromise. Basically, applying the CSM shadow and the static lighting, this is where we do the nice blending between the two to make it all look lovely. That's quite an expensive operation, and we saved kind of 5 or 6 milliseconds, which is significant on a mobile device when you've got 30 milliseconds to render, by kind of limiting the objects that can receive shadows, by limiting the objects which have this flag turned on to the ones which actually can receive shadows. So, for example, in this scene, there's a building in the background, and we know from the lighting setup there's no way that building could possibly get any dynamic shadows. All the dynamic stuff's in the foreground, right?
Yeah.
So we have that flag turned off for that background object, and there you go, the flag is turned off.
Oh, I see right there. Yep.
Yeah, but for the floor and for the walls where we do want to cast it, we have that flag turned on.
Yeah.
And yeah, so this is a pretty bad compromise, because we don't have anywhere else in the engine where you have to really be that explicit about turning on pairs of objects with like shadows and setting the shadow properties on the receiving object. So because of that, for 4.13, we've added some automatic culling. It looks at all the dynamic objects and it kind of projects them in the direction of the light and works out every frame what they're going to hit, and it only renders the expensive shader for the objects that need to be hit. So for 4.13, this flag will probably go away, and all this will happen automatically. But if you want to play with it right now, unfortunately, you need to tag the primitives that are going to receive the combined shadows.
Okay. Well, that's that's definitely a good way to solve it for now, until, like you said, you have the kind of automatic setting. But
we ran out of time to get the automatic culling in for 4.12, but for 4.13.
Yeah, better to not rush it, right? Yeah. Let's see. Does this affect the object casting a shadow on itself? Like, yeah, okay, I see. Like if you had something that's kind of like curved on itself and you had the light coming from behind it.
There are some instances where some of those dynamic spheres were casting shadows on each other. They need to have that flag turned on as well.
Okay, that's good to know. Cool.
Yeah, so the automatic culling is one of the things for 4.13. I could talk about some other stuff that's coming in 4.13 if you like.
Yeah, let's you could talk a little bit about it, but I know that we're gonna have Mike Fricker on a future stream to talk really in depth about it. So if you want to just touch on some
I'll mention only the mobile things that I know about.
All right, cool. Yeah, don't feel like you have to be pressured. You're not
the rest of the engine I don't know.
Yeah, you're not the only guy who's gonna have to come up here and talk about all the things. So you're okay. Yeah. So yeah, what's coming in 4.13 that we should know about?
Okay, so it's been confusing for a while. Under the project settings, under Android, we have this checkbox called Enable ES2. Hang on, I'll just bring it up myself so I can tell you the exact terminology. Project settings, Android. Oh yeah, support OpenGL ES2.
All right.
And then there's another option called support OpenGL ES3.1 plus AEP. Those are the two.
All right. So
those
more
are the two things
support then.
Yeah.
That's good.
So, well, the second one sounds like, hey, that's what I want. I want to support, AEP on high-end devices. So, to film people who don't know, AEP is the Android extension pack, and a lot of new devices like the S6 and S7 support AEP, the Note 4 even supports it. So everybody thinks, hey, let's check that checkbox, and that's going to give us, better quality or something. It'll take advantage of it. Unfortunately, that checkbox was added when we did the rivalry demo. I don't know if you remember that very high end.
Yep, that's what we were just showing off in the previous stream. It's pretty interesting.
Yeah. So rivalry was done for the NVIDIA K1. So it's a very powerful mobile GPU. It's not the kind of mobile GPU. It's more a PC oriented. The design is very similar to a PC GPU design compared to the mobile GPUs that are common in mobile phones. So because it was designed for that, we wanted to take advantage of the deferred renderer. So it's actually using, if you check that checkbox, it attempts to use the full power of Unreal Engine 4's deferred renderer on your mobile device. So if you check that checkbox, even though it seems like probably what you want, in fact, it'll probably make things slower. So one of the things we're doing, and so the other thing is the checkbox labeled ES2 there, support OpenGL ES2. ES2 was the first, one of the first mobile APIs available. The 3GS, the iPhone 3GS supported ES2. So it seems really old and outdated, but actually that checkbox enables our standard default mobile renderer that scales from anything from ES2 up to 3.1. So GPU particles actually are able to be rendered with that checkbox. So one of the things we're doing in 4.13 is really clarifying this. The 3.1 AEP checkbox is being renamed to make it clear that it's the deferred renderer, and we've added an extra checkbox for OpenGL ES 3.0, and it uses the same renderer as the 2.0 renderer, but it has a different set of defaults for the capabilities of the device. The biggest one is it can use 16 texture samplers, whereas ES2 gives you only 8. So that's really the main limitation of the current mobile renderer.
But I mean, it doubles the amount of samples you can use, right? So
yes,
that's cool.
So you can make much more complicated materials.
That's nice. Yeah,
it also uses.
It's pretty powerful. I'm just a little terrified at the idea, but it sounds like you're going to just kind of give them a lot of power in this update, and I guess they're kind of wondering what would you actually maybe want to use this for in a practical sense?
Well, in Protostar we've got a planar reflection. We've got the static and dynamic. So there's a planar reflection uses one texture. We're using 2 textures for the light map. We're using 1 texture for the CSM. So there goes 4 of your 8. You've got a normal map and a specular map. You can run out, right? For a complicated scene. And the other thing is enabling the ES3 or ES3.1 feature level, which is what this is going to do, just brings it into line with what we already have for Metal. So Metal on iOS has always been using this capability because all the Metal devices, the baseline for Metal devices was an ES3.1 kind of standard capability. We had this turned on the whole time for Metal. So there were times where you would find, you'd have a material that would work fine on Metal. And everything I'm saying about Metal here is also applicable to Vulkan. Moving forward, Vulkan will also be ES3.1.
Yep.
So, given those capabilities already existed, we just had no way to enable them on high-end Android devices that did not yet have Vulkan drivers, like a Note 4, an S6, an S7. S7 does have a Vulkan driver. The high-end Nexus devices.
Yeah, the S7 definitely has.
That are not yet updated to Android N. So. Yep.
I actually have the list of the supported devices here. It's the Nexus 5X with Android N Preview 3, the Nexus 6P with Android N Preview 3, Samsung S7, and the S7 Edge. But you might have to have proper drivers for it. But
for the S7, because they're not yet running Android N, and as the updates have come out, Samsung has improved the Vulkan implementation in those devices. So you probably need a driver update, but as you may know, in Android land, the drivers are controlled by the carriers. So it depends which variant you have and whether or not your carrier has released it. So it's, unfortunately, you have to wait.
You won't have to wait too long, I hope. But the driver is out there for a lot of people, so you should be able to get it most likely.
The Android N will be a big release, so I expect, that will be a major upgrade. So not only for new devices coming out, that'll be a big selling point that they'll be shipping with Android N, but the latest devices will hopefully also be upgraded to Android N. Android N has an official name, Nougat. Is that how you Americans pronounce it?
Nougat. Like we actually, we don't pronounce it with the hard A at the end. It's like nougat instead of nougat, as it should be. Yeah, I don't American pronunciation.
I'm Australian, and we pronounce it nougat, which is
you just drop the T.
Sounds very French. Nougat.
Oh, okay. I mean, I could. Sure, why not?
So I found it strange that they chose a word that's pronounced differently everywhere. But
I didn't think of it like that. I think a lot of people thought they were going to go with nerds, but then there was like a branding issue or something. Nerds would have been too on the nose, right?
Contractual issues prevented that, maybe.
Yeah. All right.
Well, they got kicked out. They must have signed something to make that happen.
Yeah. Now that I'm thinking about it, yeah. But yeah, I didn't know Nougat. And then apparently it's also Nougat in the UK, and in Scotland they pronounce it Nugget.
Nugget. Well, that's easy.
That's good. Yeah, but we got like Nougat. It's weird. But okay, but that's going to be a good build. Sorry, we got caught up in our silliness.
Yeah. But, so those devices you listed there are the ones we currently run with the Vulkan renderer. That kind of segues into the next thing coming in 4.13. How do you pronounce Nougat?
Thanks, Shelley.
Audience participation.
Yes, audience participation. Yes. So, but yeah, we have a lot coming up in 4.13, and Vulkan is a feature that's in 4.12, but it's not in the binary. It's in source, but you can get it right now. It's just that we separated it out like that. But it is in the source build off GitHub, and it will be automatically built in and turned on and ready to go in that build. So if you wanna develop for Vulkan specifically, that's the way you have to go.
Yeah. So at the moment, Vulkan's still quite early, and the drivers have until now haven't been super stable, or the drivers have been stable, but they've each required a bit of careful encouragement from Unreal to work correctly. And so 4.12 actually has an issue on the Nexus 6P, which has been fixed in GitHub. It would crash on startup because we're asking it a question slightly the wrong way, and it was unhappy with that.
Yeah.
So
fixed now.
We fixed that bug, so I suggest if you're interested in playing with Vulkan, I would use definitely you need to use GitHub source code, but I would check for that update. Or we're only a few weeks away from hopefully 4.13 previews. So.
Yeah, we are not that far from a 4.13 preview. It's a little bit terrifying over here when I talk to the build teams, and they're like, "Oh, it's coming! Oh, it's coming!"
Yeah, it's gonna be pretty hot. Yeah.
Yeah, that's gonna be a fun one.
So you might want to know what Vulkan does for you, right?
Yeah, it's got a ton of great new features.
Obviously, it's new and shiny, and therefore better. But so the design of Vulkan is it gives us a few advantages. Firstly, it works closer to the way a mobile or a GPU works, and so OpenGL is a very old API that basically, for every device, apart from things like texture format, for every device you use the OpenGL API, and then the device has to work out how to convert this API into something the GPU can understand. So the drivers become this very complicated piece of software that runs on your mobile phone, eating up your battery power and CPU cycles. And its job, or a large part of its job when it's running in OpenGL mode, is to convert every frame or every time you ask for an operation, convert that as efficiently as possible into something the GPU can deal with.
Mm-hmm.
So for Vulkan, the strategy, instead of doing that every frame, is they acknowledge that, yeah, the device has its own way, the GPU has its own way it needs to do things. So at the very start, hopefully at loading time, you build, for example, you might say, going to use this material in this shader with this blending mode, and these kind of vertices and blah, 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 all the different settings that we need to render some object. You set up all of that state beforehand once, maybe hopefully at load time, and then tell Vulkan, hey, go ahead, do whatever driver, do whatever translations you need to do to make this efficient. And then it does that once. And then later when you're rendering the frame, you just say, hey, set it up how I told you before, and it can very quickly switch the state. Okay. So because of that, every time you're rendering an object, the amount of work the driver has to do is drastically reduced, and that lets us have a lot more draw calls. So in OpenGLES, we're limited to a couple of hundred draw calls before you start running at a CPU time. But with Vulkan, with our initial work, we were seeing kind of a quarter of the, like 4 times the throughput in terms of the work that was being done by the driver. We expect that to improve based on, as we continue to optimize our Vulkan driver and those drivers get better. So as we go forward, Vulkan is going to be faster and faster compared to OpenGL. And, it's actually easier for vendors to actually build drivers because they don't have to do all this complicated work they used to have to do to infer what you're trying to do and do their own kind of caching and their own kind of state management stuff, because Vulkan makes that really explicit. So because of this, I'd expect, or we're expecting in the next couple of years, very quickly, every device that comes out is going to support Vulkan over OpenGL just because it's even easier for them to make them.
Yeah, that makes sense. It's just a transitionary period between the two that we're in right now.
Yeah, so yeah, we're in this intermediate period where it's only available on a few high-end devices, and you're going to want, maybe for game shipping with 4.13 and later, you might consider wanting to turn it on for specific devices that you've tested. Mm-hmm. And we're going to enable that in 4.13. At the moment, with 4.12, if you compile it with Vulkan support and the device says, hey, I support Vulkan, we try to use it regardless. So we don't do any kind of quality checks on the driver, or there could be a really cheap phone that says it supports Vulkan, but it actually gives you a worse gaming experience. So for 4.13, you'll be able to whitelist specific devices, like you've tested on the 6P and the S7 and know that it provides a benefit and that it works. So turn it on in that case, otherwise fall back to ES.
Yeah. And that's really good for you as a game developer. When you get onto the store and you sell, there's always so many people that will give you a bad review just because their own phone is actually the problem. Yeah. So they're trying to run, Infinity Blade on a droid, like original droid phone or something, and it's like, why doesn't this want to go? Well, it wasn't built.
Yeah, and they're given equal weight to the people who are giving you a 5-star review because your game is awesome. Right?
Yeah. So at least this way, everyone's kind of on the same playing field. They can run it, and it will be up to your quality standards. So that's good to know.
Yeah. So you're going to need to test your game to make sure it works. Vulkan does offer some other benefits for. Not only is the state managed, also the way, it's a bit complicated, but inside a mobile GPU, there's some special memory called tile memory, which can store a portion of the screen. And the way a mobile GPU typically works is it divides the screen up into individual tiles. They might be like 16 by 16 or 32 by 32 pixels. And then it renders all of those, renders the scene, the whole scene for each tile in turn, and then it writes it out to the slow memory. This is called a tile-based renderer. because of this, you have to be really careful when you change between rendering like the scene and rendering a shadow. Because if you swap at the wrong time, you might cause the GPU to have to stop what it's doing and then start rendering something else. So that involves extra reading and writing in memory and slows your game down. So Vulkan also helps with this because Vulkan lets you, instead of having to guess when the driver is going to be doing bad things, you're actually telling the driver, okay, I'm done with this data, let's start doing something else, and it can make intelligent decisions, or you can tell it exactly what you intend to do, and therefore Unreal is able to more efficiently render the scene, or more safely anyway.
Awesome. Yeah, that's pretty impressive. So let's see here. I think that's all we have to talk about today as far as
I've got a couple more things.
Oh, you got it? All right.
Yep,
Yeah.
I missed one up there.
Yeah, sorry, I was going off of our notes, and I'm like, I think that we did.
Yeah, no, I missed one.
But no, I'm all down for it. I'm sure that they would love to hear more. So yeah.
Because Android, like I said, you need to test your game on many different devices because, they've all got different capabilities and they're all running different versions of the driver and they've all got different problems. So we've attempted to work around all of these different issues in many different devices, and certainly all the common ones, but you still need to test your game on all of the target devices you want. So this becomes a problem. So, you've optimized your game or you've added some new content, you want to see what the frame rate is across 30 different devices. What are you going to do? Package it and launch on all these devices and look at the frame rate each time. So, excuse me, we decided that automated testing was something we're beginning to make more use of. You may know inside the project launcher and session front end inside Unreal front end and inside the editor, there's a couple of windows, one of which is about automated testing. And it can do things like connect to running game instances and tell them to do things, load this map or run this particular functional test, those kind of things. So we wanted to support that on Android and also iOS. 4.13 supports that on Android, so any Android device you have plugged into your phone is plugged into your computer via USB cable. You can launch on all those devices simultaneously. For example, you could package and launch one particular map, loading into a test scene to test the frame rate, and you press launch and it will go and do everything, including launching it on 10 devices if you've got 10 phones plugged into your computer, into your USB. Maybe you need a big USB hub. I saw a photograph of in headquarters. There's like a 48 port USB hub somewhere.
Yeah,
that
exists.
We're gonna utilize for this.
Yeah, I should bring it onto the stream one day and be like, look, it's just insane.
With
we need
100
this.
devices hanging. So with all these devices plugged in, once they're all launched, you can then go to the automation tab and then multi-select all of them and press go, and it will run the automation tests on all of these at once. So
that's awesome.
It's going to be a lot more efficient for testing that your game not only runs, but it performs well on these different devices.
Cool.
That's for 4.13 for Android. For iOS, it's a little bit harder to get the networking running across the USB cable. But I found a way to do that today. So I think but I think I've run out of time for 4.13, but that'll be in 4.14.
Okay,
but
that's good to know.
So.
Yeah, it's always nice kind of when you're like, oh, well, that's not good. Oh, I did fix it though. So nice, thank you. It's great. And actually, we're getting quite a few questions kind of in the same vein of basically, I see a lot of questions coming in right now that are kind of about how to get more information about the devices, what's going to be compatible, is there a way to emulate this, etc. But I think it all kind of wraps up into, I'm about to publish my game, how can I check on as many devices as possible? And I think you kind of covered that with Android, and they'll be able to do that with iOS, but that's with physical devices.
iOS has a lot less, Apple has tried hard to make every device's capability, or at least backwards compatible, right? So every new device runs exactly what the old devices did just as well, plus some new capabilities. So things are a lot easier on that side, except for performance. You still need to check that, but you don't have the issue where, particular devices don't support particular render target formats or whatever. So we have to do things a different way. So inside Unreal Engine, stuff like shadows and decals and physically based rendering, high dynamic range, mobile HDR for mobile HDR, we've got 3 different code paths depending on the devices. We do things 3 completely different ways. So often we get reports of, random device XYZ doesn't support or has some slight rendering corruption or rendering issue with this feature. And it turns out, one of the code paths isn't correctly working as well or needs a bit of attention.
Mm-hmm.
So yeah, they're right. It's a problem, and testing is the only solution to that.
All right. I mean, unless you have any recommendations for third-party hardware, but I don't know past that system.
Well, so
software.
Definitely you need to test your core. During development, you need to test your core target devices or a representation of your core target devices directly. There are cloud labs where you can upload your APK to some cloud testing service, and they'll test it on 100 devices and give you reports and screenshots back. So at a later time, you can do that. It's not something you want to be doing kind of really regularly during development, but towards the end of your release, that's definitely something to look at. But if you look at what those guys are doing, they're not doing any emulation or anything. They have rooms with USB, hundreds and thousands of USB cables and devices plugged in, right? That's how they work.
So that's basically the manual way of doing it, but making someone else do it manually.
Someone else do it. Somebody else is plugging them in and rebooting them occasionally.
Which I'm sure in the end ends up being cheaper because you didn't have to get all the devices and pay for them and then buy all the because it's so much expensive hardware to test all of that. So that's that comes from is they don't want to buy a couple $1,000s worth of cell phones to find out only a few of them actually run it and all that. So okay, that makes sense.
Okay. The first question, I'm just reading the notes here. There's another question from the stream.
Mm-hmm.
Is there any way to get more detailed information, stats information from the phones?
That's from James Baxter. Yeah.
Okay, he's saying, flush render commands is taking 20 milliseconds on some devices, and they can't get any more detail. Yeah, this is something we've really tried to push the mobile GPU and device manufacturers to expose. Sometimes they have these capabilities, and sometimes they don't actually have the capability to know how long a draw call is taking. The only way we can debug these kind of situations is by turning things off and seeing how much faster it gets when we turn things off. So using the r.show flag console command, you can toggle, you can turn off particles, you can turn off post-processing, you can turn off static measures, you can turn off skeletal measures, all kinds of things. Using that, you can narrow down what it is, but flush render commands is basically we send everything off to the GPU and then wait for it. So that's usually you're rendering more content than that 20 milliseconds is you're just measuring your CPU time waiting for the GPU to do its job. So it's the flush rendering commands itself is not taking 20 milliseconds. It's just your GPU is doing a lot of work and that's taking 20 milliseconds and we're waiting for it. So
it's like as you trim the fat, it'll go faster, basically.
Yeah, and it's a trade-off on both on CPU and GPU side. So if you reduce your CPU cost, maybe by optimizing your blueprints using the new native blueprint generator, for example, if you were to reduce the cost of your CPU, then maybe you freed up time for the driver to be rendering more objects with draw calls, even though so you had this GPU capability available, but you couldn't make use of it because the CPU was already fully taxed. So that's the great thing about Vulkan is it lets us be 100% GPU bound all the time, which is what we want to be. We want to be using all the graphical capabilities of the device
Mm-hmm.
rather than treating it or using it as a complicated CPU and then having this capability of the device we're not utilizing.
Yeah. Yeah. All right. Cool.
Okay. Oh, and one other thing, where you're going to show a couple of
Oh, yeah.
complicated mobile games, right? In a minute. There's
In
a
1
couple
second.
of videos.
I see Shelly's over there. Press
Ready with the
press the button.
play button. Yeah. So in Asia, people are making very complicated mobile games, like hack and slash kind of games with. Even though they don't have online play necessarily, they've got they're like an online game in terms of persistent character, and you're always connected to the games, some kind of game server.
Yep.
So they want to push new content really often, and they want to push updates to their game really often, and they don't want people to have to launch their game and then get a message saying, "Oh, you need to update your app to continue playing." It's like the worst message in the world. So the way they do that is they make a minimal APK or IPA, that is the binary file that gets uploaded to the Play Store or to the App Store.
Mm-hmm.
They have a kind of minimal version of that contains nothing except the game code and enough user interface to show some download progress bars. And then everything else they download from a cloud based service, so that they can, like we do with Paragon, we can push new updates as frequently as we want without having in this case, without the user having to go to the App Store to update their app. They can just get the latest content. So to support this, in 4.13, we're going to add a little wizard to the session front end. It's not the session front. What's it called? We've got three things. The project launcher. There we go. Project launcher is a part of Unreal front end and the editor, which lets you select how you want to package and what maps you want to include, and then there's a go button that will go off and package things. So this little wizard is a front end to that kind of complicated user interface. It asks you some questions about what maps you want to load in your small APK and what texture formats you want to support, and then it goes off and packages all of these different combinations ready for uploading to a cloud service. So it might seem like, oh, we magically solved this problem, and we kind of half solved the problem. The client, which runs and needs to download this content, still needs to have some code added to it. So for 4.14, we're going to improve that more. But certainly, this is a big step towards making these kind of complicated games easier to make. These two games we're about to show you both use this kind of strategy. So we've worked with them to set it up, but they required a lot of manual configuration. So this wizard is going to make it a lot easier to set this up.
Yeah. All right, you ready to show the clips now, Jack?
Sure.
All right, let's show some clips. So the first thing we've got up is Project Hit. It's a very intense hack and slash game. Shelly.
This is from Nexon. Yeah, it's available on iOS and Android, and it's actually, I don't know if it's released on the US app stores or not, but it's, I'm not sure if it is still now, but for a while it was the #1 mobile game in Korea. Is UE4.
Oh yeah,
obviously it's a little bit
fantastic.
It's a little bit different to the kind of games that most people play on or think about playing on mobile in the West, but this is the direction they're going in Asia, for treating it like a console.
Oh yeah, it definitely plays much more like what I would expect from, I don't know, like an over-the-top hack and slash from a PS2 era versus like a more modern mobile title. Yeah.
I think your memory is failing. Your PS2 didn't look that good.
I have like that kind of nostalgic haze over what Dark Alliance looked like, and maybe that's what I'm seeing. And I'm like, oh wait, no, it's maybe not that much pop and flair.
It's amazing when you go back to old games and
you
think about how awesome
they were so
they
great.
looked at the time.
And then you go play it again, and it's like, wow, the pixels are as big as cats. Yep.
Yeah, exactly.
Yep. It's very blocky. Yeah, awesome. And so we have another quick clip of Blade 2.
Yeah, so that first game, that
Yeah.
Project Hit is already out, so that's
Yeah.
running on people's current devices. I see people on the subway playing it.
Hmm.
This next one is Blade 2, which is in development. This is a sequel to an Unreal Engine 3 game that came out last year, which was the first of these kind of games
Yeah. And
that saw our customers making.
yeah, and the thing to take note of before we even play the clip is keep in mind that these are basically the in the game graphics, like, and all that we're going to show, because I didn't realize it at first because it's so high quality. So when we
when I first saw this, I thought this looks amazing. It can't look this good on the phone, but
that's the gameplay.
Tim Sweeney, our CEO, was in Korea a few weeks ago, and he went to the studio and took a look, and he said, "Yeah, it looks like this." So, obviously they're making really good use of the physically based renderings with the, really nice lighting and reflections there. That's
Cool.
as much as we're going to show. It's a very Asian art style.
Yeah, it's very anime-esque, but still pseudo-realism in there too, and it's very cool. And then yeah, if you want, there's some full trailers out there for Blade 2. You can look them up. They're really it's really nice, very sharp graphics. Again, we were seeing gameplay in there, and you can just see how incredible it is. Just between particle effects, shadows, material usage, it's incredible to see on an actual mobile device. So. And Jack, quick question here.
Mm-hmm.
So, yeah. So, what can you tell us about of what you know about Blade 2 and what they've been utilizing as far as these new rendering features go?
So they've been in development for a while. They're doing something very similar with their shadows, I believe,
Mm-hmm.
to get the high quality shadows with the environment. Although they've been in development in parallel with us, which means they've ended up adding a couple of features the same way we did, which is kind of inevitable for AAA studios sometimes to be, when they want to be on the cutting edge, they want to have the best looking, to be the best looking mobile game out there.
Mm-hmm. Mm-hmm.
So they have, they've added a couple of, I think, we had some early discussions with them, and that what we ended up doing was the same recommendation as what we ended up doing ourselves with this combined CSM plus static lighting or static shadowing. Apart from that, I think they're just making really good use of the mobile materials or the material system
Mm-hmm.
to, show really very nice reflections and those kind of things. The specular looks really nice. The lighting looks really nice. It's just careful attention to detail.
Yeah.
The truth is mobile devices are actually really, really powerful. If you keep your draw calls under control for OpenGL, there's less of an issue with Metal and Vulkan. You keep your draw calls and translucency under control, your actual base environment can use pretty high quality shaders and look really good.
All right, and so yeah, that's pretty cool. Like it's overall, they're probably using just kind of the same techniques we've talked about earlier, plus just taking advantage of the overall optimizations that have been made on the newer versions of the engine for mobile. So yeah.
Awesome. Version 4.9 or 4.9, I can't remember which, added something called mobile quality levels.
Mm-hmm.
And this was the ability for different devices to choose different quality levels of shaders.
Yeah.
So you could have very complicated shaders that you only enable for your high-end devices, and with a quality switch node or the quality level overrides, you can reduce the quality for medium and low-end users, and then the device profile can choose whether they want high, medium, or low shaders, and that goes a long way to improving performance on the low end, because most of the cost for the GPU is the shaders, right? Is the materials. So I'm pretty sure they're using the quality. So I'm sure what they've shown us here is running on, a nice high-end iOS or Android device.
Yeah, so some kind of like S7 or something pretty new. It's powerful enough to render all those features, because it's clearly set on the highest settings when they're rendering it here.
Sure, but with the quality levels, you can, like you would in the old days like you do on PC games, you can dial down the shaders and the graphics to free up some of the GPU time for the slower devices.
Yeah, and that's just a pretty fun little built-in feature. It's been in there, like you said, since 4.9 or 4.10, so it's pretty useful in general. Cool. And yeah, so that's about it. There is a question if you're aware of any open world mobile games made with UE4, which open world, I'm not sure if I've seen any, but I don't know if maybe you've seen any over in like Asia, but over here in the West, I don't think I've seen many.
I just have to Google this to see if it's public knowledge or not before I can mention the name of this title. Just a second.
You gotta. Okay, I know that feeling though. It's like, oh wait, he told me about it, but did he tell the world about it? Yeah. So let's take a look. See here.
Oh yeah. Okay. So yeah, no, there were press releases last year.
Okay.
So Lineage 2 was the first MMO to use Unreal Engine. A long while back, out of Korea. NCSoft is the name of the developer. They are partnering with another Korean developer called Netmarble to make Lineage 2 mobile.
Oh, okay.
And that's in development now. We're really excited about having a true MMO open world game running on a mobile device.
Yeah, Lineage is a huge IP. It's awesome.
Sure. So yeah, I'm glad I Googled that. Good.
I'm glad you double checked on it though. But yeah, that's amazing. I'm excited.
So
for
yeah,
that.
so those kind of things are in development, and those kind of games are quite suitable to tablet and phablet, large phone kind of experience. That is pretty decent form factor for that kind of game, I think.
Yeah.
Especially if you can simplify the combat systems to,
Yeah, to work on the touch screen and all that, and that'll be impressive to see. So yeah, to answer your question, we'll be seeing something in the future in the way of Lineage. And if you're not familiar with Lineage, please look it up. I kind of grew up on that one, so it's good. It's good.
So the the first game I showed you, Project Hit, the first video there was. So I was talking about, controls for the combat system, how to do different kinds of attacks and stuff. Most players you see on the subway leave it running in autoplay mode. There's just like a button you press autoplay and it'll just hack and slash and do everything you need. And then they're interested in spending the time making more strategic decisions than actually controlling the hacking and slashing.
Yeah, I could see how it's that kind of, you don't need to just keep mashing it kind of.
Exactly.
You'd rather be there using
if it's just going to be mashing
to
make the control.
Yeah. All right, cool. All right, I think that's what we've got for today to show off and talk about. Unless you got anything else, Jack?
That's about it.
All right, cool. So that's about it. Also, my monitors decided to die, so that's how we know it's time to call it a day anyway. Just pop back up. Cool. So, yep, next week on Tuesday, we will be trying again and actually properly having the training stream, unfortunately, on Tuesday. I'm so sorry again, Shelly, on Tuesday. Yeah, not your fault, not mine, but still, it happened, and it was an unfortunate thing that we unfortunately did not have a Tuesday training stream due to some technical difficulties over here where we went through some hardware issues, but it's been solved, and so Tuesday we will be having the VR stream with Ryan Brooks and Wes Bunn, and they will shoot stuff with arrows. They have giant spiders come at you, so it'll be really fun to see that. So there's that, and then next Thursday we'll have some really cool announcements to make. I can't talk too much about it yet, but stay tuned. Thursday will be a kind of a big fun one for us too. So see you Tuesday.